Welcome back to Discovering Geometry with Becky Berry. This is Lesson 3, all about angles. People use angles every day. How, you might ask? What about the air traffic controller who needs to be able to predict where airplanes will be and to redirect them by giving them new angles? The pool player who has a secret formula that's really all about angles. Or even the plumber who needs to make sure to use the right fitting to direct the pipes to the right places. But what is an angle? An angle is formed by two rays that share a common endpoint, but they're not collinear. Here is my first ray. This is the endpoint, and it goes in this direction. If I had a collinear ray, it would be right on top of it, but that's not one to form an angle. If I have a different ray that starts here and goes this way, now I have a common endpoint, but two different rays. So that forms an angle. The vertex is the common endpoint. Right here is my vertex of the angle. It's the point where they come together. And the sides are the two rays of the angle. So here's one side and here's the other. This angle can be named two different ways. First, we use our angle symbol and we can name it as JHK. So I went from one side through the vertex to the other side, or I could name it KHJ, from this side, K, to the vertex to the other side. The letter in the middle is always going to be your vertex. You want to go from one side through the vertex to the other side when you're naming your angles. What about measuring angles? We measure angles in degrees with a geometry tool that we call a protractor. The measure of an angle is the smallest amount of rotation about the vertex from one ray to another. So here on this angle, angle ZAP, we could measure from this ray to this way, or we could measure from the ray AP to the ray AZ this way. Which one's going to be the smaller one? Obviously this one in between. So that's going to be 34 degrees is the measure of this angle. When measuring an angle, we want our protractor to have the vertex lined up in the middle. I have another protractor that has starting at the bottom, but on this one, we know that we'd put the vertex right here. And the reason that I know it's up here and not down at the bottom is because this comes out right at 0. Then we're looking at where that top line goes. We're looking and we see that it's one mark below that major mark. The major mark is, it's either 150 or it's 30. So how do we know which one it is? It's either 0 to 1 before 30, or it's 180 to 1 before 150. Which one makes sense? Well, we have an acute angle here, so it's less than 90 degrees. We know that it's then going to be that 31, but remember, it's 1 before 30. Between 0 and 30, 1 before would be 30 minus 1, or 29. So this angle measures 29 degrees. Here's an angle from the other side, or the other view. Again, we're going to get our protractor, and we're going to line up the vertex right in the center. Sometimes there's even an X in the center of your protractor to show you exactly where to put it. And we line up that bottom line with the 0 marking. Then we start to read our other line. So it's either 50 or 130. And how do we know which one it is? Well, it's less than a square angle, or it's less than 90 degrees. So we know that it's the 51, not the 130. We look for our major mark. We see it right there, and it's 2 below that major mark. So between 0 and 50, 2 less would be 48. This angle measures 48 degrees. Congruent angles. How do we know that two angles are congruent? Well, they have to have the exact same measure. Here we measured this angle at 60 and this angle at 60. Even though they're not pointed the same direction, we can measure them, and if the measure is the same, they're congruent. We also, remember how we marked congruent segments, where we might use one line for both of them, or even two little tally marks if you like that. We're going to use a similar marking for angles. We're going to draw a little arc across the angle. I'm going to go ahead and draw 2 on this one. And since this is congruent, I'm also going to draw 2 on this one. If I had another pair of angles that were congruent, I would need to mark them with a different symbol within the same problem. So maybe 1 for these. An angle bisector divides an angle into 2 congruent angles. Let's look at all these pictures. Which rays are angle bisectors? Which angles are congruent? On this first picture, do we see any congruent angles? They might look close, but they're measured at 43 and 44 degrees, so they are not congruent. Remember, our congruent symbol looks like an equal sign with a little tilde or squiggly line over it. What about these? Are these congruent? They are. They measure exactly the same. So angle SRP is congruent to angle QRP. Does that mean that we have an angle bisector? It sure does. That ray in between, our ray RP, is an angle bisector. And in our last picture, do you see angles that are congruent? I do too. YMN has one marking and OME has another marking that's the same. So those angles are congruent. Where is the angle bisector? Well, there's not just one ray that bisects it, so I can't find the angle bisector in this picture, even though we have congruent angles. Don't forget, you need to be reading the lessons in your book because I don't always show the same pictures, so I want to make sure that you get all the information. And you need to always try the investigations. This lesson, which is lesson 1.2, has an investigation on playing pool and using the incoming angle and the outgoing angle. Make sure you look over that so that you know what those terms mean.